What if the most destructive things in the entire universe were also time machines? It sounds like something straight out of science fiction, but scientists are confident that if you could fly a spaceship very close to a black hole and then come back to Earth, you would have jumped into the future. Seriously, this isn't a movie plot. It's a very real consequence of Einstein's theory of relativity. Today, we're going to break down exactly how this works. This is a journey to the very edge of physics, where time itself gets weird, and the future becomes a place you can actually go. Get ready, because your understanding of reality is about to get warped. For almost all of human history, we've thought of time as this universal constant, a cosmic clock that ticks at the exact same speed for everyone everywhere. A second on Earth is a second on Mars, is a second in some galaxy a billion light years away. It's like an invisible river flowing in one direction, carrying all of us from the past through the present and into the future. This idea was simple, reliable, and, as it turns out, completely wrong. The person who blew up that idea was, you guessed it, Albert Einstein. In the early 20th century, Einstein gave us his theory of general relativity, and with it, a totally new way of looking at the universe. He said that space and time aren't two different things. Instead, they're woven together into a single four-dimensional fabric he called space-time. And here's the kicker. This fabric isn't flat. It can be bent, stretched, and warped by anything with mass and energy. The classic way to picture this is to imagine a bowling ball on a trampoline. The ball makes a big dent in the fabric. Now, if you roll a marble nearby, it won't go in a straight line, will it? It'll curve, pulled into the dip made by the bowling ball. That, Einstein said, is gravity. It's not some mysterious force pulling things together, it's just what happens when objects follow the curves in space-time. Planets orbit the sun not because it's yanking on them, but because they're following the straightest possible path through the curved space-time created by the sun's massive weight. But this is where it gets really weird. Einstein's theory didn't just say mass warps space, it said mass warps time. The stronger the gravity, the slower time actually flows. This is called gravitational time dilation, and it's not a theory, it's a fact. It's been proven. Atomic clocks on airplanes flying high above the Earth where gravity is just a little bit weaker tick ever so slightly faster than clocks on the ground. Astronauts on the International Space Station are aging just a tiny fraction slower than the rest of us. The difference is microscopic, but it's real, and it proves Einstein was right. Time isn't absolute, it's relative, and gravity is its master. So if we know that gravity can bend time, the obvious next question is, what happens when gravity gets extreme? What happens when you crush the mass of a billion suns into a space smaller than our solar system? You get a black hole, the most extreme gravitational environment in the known universe. A black hole is what's left behind when a giant star dies and collapses in on itself. It's so dense that its gravity warps space-time into a one-way cosmic trapdoor. The edge of this door is called the event horizon. Think of it as the universe's ultimate point of no return. Anything that crosses it, a star, a planet, even light itself, can never ever get out. It's pulled down toward the center, a point of supposedly infinite density called a singularity. Now, if you were watching safely from a distance as a spaceship fell toward a black hole, you'd see something bizarre. You wouldn't see it crash. As it got closer to the event horizon and sank deeper into that gravitational well, you'd see it start to slow down. The light from the ship would get redder and dimmer. It would move slower and slower until, right at the edge of the horizon, it would seem to freeze completely, stuck there for all eternity. From your perspective, it would take an infinite amount of time for the ship to finally cross that line. You'd never actually see it disappear. For the poor astronaut inside, however, their trip across the event horizon would feel totally normal, even though their fate would be sealed. This massive difference between what the astronaut experiences and what you see is our first big clue that black holes do something truly wild to time. And this brings us to the heart of it, how all this space-time bending turns a black hole into a time machine. It's all about that gravitational time dilation we talked about, but cranked up to 11. We know stronger gravity means slower time, and there is nowhere with stronger gravity than near a black hole. So let's imagine a mission. You're an astronaut on a super advanced ship that can handle the ridiculous forces near a black hole. You travel to a supermassive one, like Sagittarius A star at the center of our own galaxy. You don't fall in. Instead, you put your ship into a stable orbit, just outside the event horizon. For you on the ship, time feels normal. You start a stopwatch and exactly 1 hour goes by. You run your experiments, you take some readings, and after your hour is up, you fire the engines and head for home. But when you get back to Earth, you find the world you knew is gone. While you only experienced 1 hour, back on Earth, where gravity's a tiny fraction of what you experienced, time was screaming forward. Decades, centuries, maybe even thousands of years could have passed. Your friends, your family, everyone you ever knew, they'd all be history. You would have used the black hole's gravity to take a giant leap into Earth's distant future. This isn't just a fun idea, it's a direct prediction of general relativity. The movie Interstellar famously showed this, where 1 hour on a planet near a black hole was equal to 7 years on Earth. The exact numbers might have been dramatized for the movie, but the science behind it is solid. By flying to a place with insane gravity and coming back, you would have traveled forward in time. From this point of view, black holes aren't just cosmic monsters, they are one-way tickets to the future. If your mind is as bent as spacetime right now, do us a favor and hit that subscribe button. We tackle the biggest questions in the cosmos every week, and you won't want to miss what we explore next. Tan. So we've pretty much established that traveling to the future is possible, at least in theory. All you need is a spaceship with some incredible new form of propulsion to reach a distant black hole in a human lifetime. The ability to orbit it without getting torn to shreds, and, a willingness to say goodbye to everyone and everything you've ever known. It's a wild thought. The universe itself has given us a way to do it. But this time machine comes with some pretty big warning labels. First, and this is the big one, it's a one-way trip. As far as we know, there is no law of physics that would let you use a black hole to go back to your own past. Once you've skipped ahead to Earth's future, you're stuck there. The classic grandfather paradox, where you could go back in time and accidentally prevent your own birth, stays safely in the realm of science fiction. Second, getting close to a black hole is, to put it mildly, dangerous. The same forces that warp time would also create insane tidal forces that would stretch you and your ship apart. The pull on the part of you closer to the black hole would be so much stronger than the pull on your feet that you'd be stretched into a long, thin noodle of atoms, a process that physicists, with a dark sense of humor, call spaghettification. To even have a chance of surviving, you'd need a supermassive black hole, where the tidal forces at the event horizon are gentler, but the danger is always there. So while black holes are time machines, they aren't exactly tourist-friendly. But what if there's more to the story? What if, hidden in the math, there's a way to do something even crazier than visit the future? Okay, now we are officially leaving known physics behind and venturing into the wild frontier of pure theory. The black holes we've been talking about are the simple, non-rotating kind. But in the real universe, most black holes probably spin, some of them incredibly fast. These are called Kerr black holes, and their physics get even stranger. A spinning black hole doesn't just warp spacetime, it actively drags spacetime around with it in a cosmic whirlpool. This is called frame dragging. Get close enough and it becomes physically impossible to stay still. You are forced to go along for the ride. But the truly reality-shattering idea that comes from the math of spinning black holes is the possible existence of closed timelike curves, or CTCs. A closed timelike curve is what it sounds like, a path through spacetime that loops back on itself, allowing you to return to your own past. According to the equations deep inside a rotating black hole, these paths could exist. If you could somehow pilot your ship along one of these loops, you could theoretically come out of the black hole before you went in. This, of course, throws open the door to all kinds of paradoxes. Could you go back and give yourself the winning lottery numbers? Or worse, could you stop your own mission from ever happening? Physicists are really divided on whether CTCs are physically possible. Many, like the late Stephen Hawking, have argued for a chronology protection conjecture, which basically says that some law of physics we haven't discovered yet must step in to stop these paradoxes from happening. Maybe the universe has a self-defense mechanism. So, is travel to the past possible? The best answer we have right now is a firm maybe, but probably not. While the math allows for it, it seems to break the most fundamental rule of the universe. Cause has to come before effect.
So are black holes time machines? The answer is yes, with an asterisk.
The incredible gravity of a black hole is scientifically proven to slow down time, making it a natural one-way ride into the future. That's a direct prediction of general relativity, a theory that has passed every single test we've ever thrown at it. The journey would be incredibly dangerous, and the personal cost would be enormous. But the physics works. The idea of traveling to the past, though, is still just a fascinating and deeply problematic theory. It comes from the same equations, but it seems to violate everything
everything we know about causality. It might just be that the universe has built-in safety features to keep its own timeline from being messed with. Black holes push our understanding to the absolute limit. They're a reminder that the universe is far stranger, more complex, and more wonderful than we can even imagine. And they prove that time travel isn't just a fantasy. For anyone brave enough, the future is already out there, waiting. So I'll leave you with this question for the comments. If you had a one-way ticket, what future would you want to see? Thanks for joining us on this trip to the edge of time. If you want to keep exploring the biggest ideas in science, make sure you're subscribed and we'll see you in the next one.